Have you ever wondered why salt is spread on icy roads or why seawater freezes at a lower temperature than pure water? In this video, we will explain the concept of freezing point depression and learn how to solve problems using it. So what is a freezing point depression? It is the lowering of the freezing point of a solvent when a solute is added to it. For example, pure water freezes at 0 degrees Celsius, but when salt is added, the freezing point becomes lower than 0 degrees Celsius. This happens because solute particles interfere with the formation of ice crystals. So, the formula for freezing point depression is equal to the Van 't Hoff factor, or the number of particles formed, multiplied the freezing point depression constant of the solvent, wherein the water is equal to 1.86 degrees Celsius times kilograms per mole, multiplied to the molarity of the solution. And to find the new freezing point, we have the formula of original freezing point minus the freezing point depression. So let's have an example number 1. A student dissolves sugar in water to make a sweet solution for the experiment. Sugar does not ionize in water, so its Van 't Hoff factor is 1. The solution has a molarity of 0.50 moles. So for the given, the Van 't Hoff factor is equals to 1. The freezing point depression, or constant of the solvent, is equals to 1.86 degrees Celsius times kilograms per mole, and the molarity of the solution is equals to 0.50 moles. After getting the given values, we will just use the formula presented earlier. So we have here freezing point depression is equals to 1 times 1.86 times 0.50 moles is equals to 0.93 degrees Celsius. And for the new freezing point, we have an original freezing point, which is 0 degrees Celsius minus 0.93 is equals to negative 0.93 degrees Celsius. So for example number 2, during winter, salt is spread on icy roads to prevent freezing. Suppose the salt solution formed has a molarity of 0.20 moles. Since NaCl dissociates into 2 ions, its Van 't Hoff factor is 2. We will just follow the formula and we will substitute the given values. So we will get an answer of 0.744 degrees Celsius for the freezing point depression. And for the new freezing point depression, it is 0 minus 0.744 equals to negative 0.744 degrees Celsius. For third example, in a laboratory, a chemist prepares a concentrated solution using a non-electrolyte solute. The solution has a molarity of 1.5 moles and a Van 't Hoff factor of 1. So we will just substitute the given values of the given formula and we will get an answer of 2.79 degrees Celsius for the freezing point depression. And for the new freezing point depression, we will subtract it from the 0 and we will get an answer of negative 2.79 degrees Celsius. Next example. Calcium chloride is used to melt ice on roads. It dissociates into 3 ions in water. If the solution has a molarity of 0.30 moles, how much will the freezing point decrease? So the same process, we will just substitute the given values to the given solution or formula and we will get an answer of 1.674 degrees Celsius for the freezing point depression. And for the new freezing point, we will just subtract it from 0 and we will get an answer of negative 1.674 degrees Celsius. For our last example, scientists study seawater by preparing a salt solution in the lab. If the solution has a molarity of 0.40 moles and the salt produces 2 ions, what is the freezing point of the solution? So the same process, we will just substitute the given values, which are the molarity is equal to 0.40 moles and the Van 't Hoff factor is equal to 2 ions. We will get an answer of 1.488 degrees Celsius for the freezing point depression. And for the new freezing point, we will get an answer of negative 1.488 degrees Celsius, wherein the original freezing point is 0. So, freezing point depression happens because adding a solute lowers the freezing point of a solvent. By using the formula, we can easily calculate how much the freezing point changes. And that's all for this video. Thank you for watching.